Okay, so I left off on talking about the range of these functions. So number 13, because it's a parabola, its range is a little bit different than all real numbers because it's either going to open up or open down, and we know that because the leading coefficient of x squared is positive, that it's going to open up. So when we look at the graph, excuse me, we can see that its lowest point is right here. It looks like it's probably at -1, 0, but let's make sure. So we're going to go second calc minimum, which is choice 3, and I'm going to go to the left and to the right, and then it looks like it is -1, 0. So the range goes from, for this one, the range is 0 to infinity. 14 is a parabola, and we know that it moved right 2 and up 5, and it opens up. So this range would be from 5 to infinity. And again, you can look at the graph if you want to be sure about that. 15, it's an absolute value equation that got vertically stretched by 3 and moved up 8. So its range is going to be from 8 to infinity. 16 is a little bit harder, just like it was for the domain. We're going to look at the graph of negative square root of 4 minus x squared. And as you can see, the range goes from here to here. So we would say that range is from -2 to 0. -2 to 0 for the range. For 17, I think that's just going to end up being, well, let's look at it. X over x squared minus 2x. Okay, so you can see that the range starts down here all the way at -infinity and comes up, and then it goes asymptotic to the x-axis, and then it starts way up here and comes down and goes asymptotic to the x-axis. So the only value of y that will never actually be touched is 0. Now, there's another little one right here. Remember we talked about that hole? So y will also never equal a half, but if you missed that one and only said 0, I would be okay with it at this point. So the range for this one is all real numbers. Y does not equal 0. Let's look at 18. 1 divided by 9 minus x squared. Square root of 9 minus x squared. Sorry about my breathing. I forget to breathe and then I have a huge sigh. Okay, so that goes from 0 up to whatever point this is. Let's trace that. So as x goes up to 3, y approaches 1 point. Well, let's see what happens. We know that the biggest value x can take on is 3, because it's not defined at 3. So let's just check. Well, so we know the range is going to go up to 1 point. Let's look at the table. So 0.45 and Gets bigger than that though, doesn't it? This is a really hard question. I'm not gonna ask you to do this. But let's just see what y is when x is 2.999999999. What? That's not right. That is very strange. Because y does not have a value when x is that. Let's just try 2.9. .30. So I would just say the range goes from 0 up to 1.30. It's a tricky question. And there's an algebraic way to do it, but I really don't want to get into that. So the range is from 0 to 1.30. It will never actually equal 0. But for instance, if x was a million, if x was negative 2.999, when you square it, it becomes positive like 5, and then, it's a really interesting graph. Sorry, I'm like perplexing over it because it's really beyond what we're ready to do in this class, but 0.3 is the minimum. The range will never get below 0.3. Repeating. So we're going to say the range goes from 1/3 to 1.3. Well, that makes sense. The range goes from 1/3 to 1.30. Wow. Okay, moving on. Sorry, that was a little too much time on something that wasn't that important. Graph the function and find when it's increasing. So we're going to look at the graph, x cubed over 6. The only problem with this new update is that it puts something in the numerator that I don't want there, in the exponent that I don't want there. Okay, I'm just talking to myself. Graph. We need to know, when is it increasing, when is it decreasing? Now it kind of looks like it might turn and have a minimum or a maximum in here, but this is when it's a good time to go to your table and notice that even as x goes from -7 up to +7, y is always increasing. It's always getting bigger. So we would say it's increasing from -infinity to infinity. 25 is -infinity to infinity. 26, I know what that looks like. I don't even have to look at the calculator, but I'll remind you how to do it. 2 plus absolute value of x minus 1. So we're going to go 2 plus math num abs x minus 1 graph. So it is increasing from 1 to infinity. Remember, increasing and decreasing is always parentheses. X over 1 minus x squared is increasing from -infinity to -1, union 1 to 1, -1 to 1, union 1 to infinity. So it's increasing everywhere, but it has asymptotes at -1 and 1. So we would write that like this. It's increasing from -infinity to -1, union -1 to 1, union 1 to infinity. That's when it's increasing. And finally, x squared minus 1, x squared minus 4. squared minus 1 divided by x squared minus 4. So that is increasing from negative infinity to negative 1, and from negative 1 to 0. Then it's decreasing from 0, oh sorry, that's negative 2. So can I write on here? Let's do this. It's increasing from negative infinity to negative 2, union negative 2 to 0. And then it's decreasing, which this question doesn't ask, but let's talk about it anyway. Decreasing from 0 to 2, union 2 to infinity. It's always going down. From here to here it's going down, and from here to here it's going down. Okay. Next question. Graph it and state whether it's even, odd, or neither. Remember, in order for it to be even, it has to be symmetric to the y-axis. In order for it to be odd, it has to be symmetric to the origin. Otherwise, it's neither. 3x squared minus 4, absolute value of x. 3x squared minus 4, math num abs x. Delete, delete, delete. Oh my goodness, it's so hard to delete. I should have just cleared it all first. Delete. Okay. Graph. That doesn't like that I left that empty blank there. Delete. There we go. Very interesting little shape. That is going to be even, because if I fold it over the y-axis, it will land on itself. So that one's even. Sine x minus x cubed. Make sure you're in radian mode. Right there, make sure it says radian, otherwise sine of x won't look right. I'm going to clear it this time, and I'm going to go sine x minus x cubed. Forgot my parentheses. That's interesting. That's actually going to be an odd function, because if you turn it and rotate it all the way 180 degrees, it looks exactly the same. So that is an odd function. Now it's weird because that goes down a little farther than that appears to right there. So we're going to leave it as an odd function and not worry about it. X over e to the x. X divided by e to the x. That one's going to be neither. I can tell right now that if I rotate it, it doesn't look the same, and I can't reflect it across the y-axis. So that one is neither. And then x cosine x. That graph appears to be I'm going to go with neither on that one too. Well, you know what? It looks like it might be odd. It looks like if you rotate it 180 degrees, you would get the exact same graph. That is an odd function. That's pretty cool. Now again, let's remember how we can check it algebraically. So we can say f of negative x equals negative x times the cosine of negative x. Now we haven't really done trig, but you should know, well you shouldn't know yet, but you will know that the cosine of x, the cosine of negative x is the same as the cosine of x. So this is just cosine x. So now we have negative x cosine x, which is the negative of the original function. The original function was x cosine x. Our answer is negative x cosine x. So what we found is that f of negative x equals negative f of x, and therefore it's an odd function. Let's go back and look at the sine one, just to prove why it's even, I think we said. So we want to find f of negative x equals sine of negative x minus negative x cubed. All I did was plug in negative x here and here. Now the sine of negative x is actually the opposite. It's the negative sine of x. And you're just going to have to take my word for that because you haven't talked about trig yet. But negative x to the third is negative x. So this minus and that minus become a plus x. Oh, so that was also an odd function because negative f of x for this would be negative sine x minus x cubed. When you distribute that negative, you get negative sine x plus x cubed, so that's also an odd function. Pretty cool. Alright, let's do the inverse for 41. That little f negative one there just means the inverse. So what's the inverse of 2x plus 3? Well, y equals 2x plus 3. Switch x and y, and solve for y. And there you go. 42. We would say, I'm going to switch x and y, so y equals the cubed root, x equals the cubed root of y minus 8. I'm going to cube both sides to get rid of that cubed root, and then I'll add 8. So y equals x cubed plus 8. That's the inverse. Over here we have y equals 2 over x. Switch the x and y, so x equals 2 over y. Solve for y. In order to solve for y, I'm first going to multiply both sides by y, and then divide by x. So in this case, the inverse and the original function are exactly the same. That can happen. It's very possible. Okay, and then finally, x equals 6 over y plus 4. This one's going to be hard. So we're going to multiply both sides by y plus 4. Then I'm going to distribute. Then I'm going to subtract 4x. I'm going to divide by x. So the inverse is y equals 6 minus 4x over 4. Alright, next slide. We're going to sketch the graph of the inverse. I'm sorry, we're not going to sketch the graph of the inverse. We're going to sketch the graph of this function moved down 1 unit. So everything would move down 1 unit. Will look just like that. For the next one, everything is going to move to the right 1 unit. So it would go to the right 1 unit. Look like that. F of negative x, that would get reflected over the y-axis. So it would come over here, and then It would go up like that. And then 48 would get reflected over the x-axis. So that one, this point would come up here. This point would come down here. This point would come down here. This curve would come down like that, and like that. That's how it would look reflected over the x-axis for 48. Don't worry about 49 and 50. Moving on. Was that really it? No, you had more, didn't you? I didn't bring the packet with me. Phew. I lost the rest of this. Okay, f of g of x. I need to turn my thing around here. Everything's going to flip upside down on you now. Hope that's okay. Okay, so f of g of x means f of x squared minus 4. So it's the square root of x squared minus 4. And the domain is x must be greater than or equal to 2, or less than or equal to negative 2. So the most restrictive so that's the domain for that one. Okay, I'm back. So this is the domain. It has to be from negative infinity to negative 2, union to infinity. How about g of f of x? So that is square root of x squared minus 4. Well, square root of x squared is x minus 4. But you still have to have x greater than or equal to 0, because this wouldn't be defined if x was less than 0. F times g of x. That's exactly what you would think. It's just square root of x times x squared minus 4. And again, its domain would be greater than or equal to 0 because this function has to be defined. And then f divided by g of x, that one's tricky. Square root of x over x squared minus 4. So x has to be positive in order for the top to be defined, but it cannot equal 2 because that would make the denominator equal to 0. So the domain would be from 0 to 2 union to infinity. Okay, this one's tricky. You have to know the volume of a cylinder, which is, if I did this on a test, I would give it to you. But the volume of a cylinder is pi r squared plus... Alright, so here's how I do it. I know the cylinder has a base that's a circle, and the volume is area of the base times the height. So the area of the base is pi r squared, and the height is the same as the circumference of the circle. No, the height is the height. I'm thinking of surface area. Yeah, so it's just pi r squared h for the volume. Area of the base times the height, pi r squared h. So it has a diameter of 20 feet. That means r equals 10 feet. Partially filled with oil to a depth of h feet. Write the volume as a function of h. So y equals 100 pi h. That's the volume of the tank as a function of h. Okay, that's how you would do that. Alright, last one. Sketch a scatter plot. So let's review how to do this. We are going to go... Oh, it drives me crazy. Slowly. Nope, don't get big. Just move right over there. Don't get big. Right over there. Don't. Okay. So I'm going to go to Stat. Of course, I'm too far off. Edit. And in L1, I'm going to put all my X values, which are the years, and it says years since 2000. So that means 2000 is year 0, 2001 is year 1, and so on up to 8, which I already have in there, so that's nice. And now I'm going to delete the rest of these. And then over here, barrels per day. Oh jeez. 1, 2, 6, 7. 1, 2, 9, 7. I suppose I should pause this while I do this, but oops. You're going to be hopefully entering these too. Actually, I'm going to pause it because you already did. Okay, we're back. So I have all the data entered, and I want to sketch a scatter plot. So I'm going to go to Graph, see what happens. Now remember, I still have my y equals from the last time up, so I'm going to clear that, and my plot 1 is not on, so I need to make it on. Then I need to adjust my window. Now the x values go from 0 to 8, so I'll go from 0 to 10 on my calculator. And the y values go from 1,267, so I'll say 1,000, up to 2,000. There's the scatter plot. Find the equation of the regression line. So stat, calc, linreg. I want the equation to get stored into y1, so vars, y-vars, y1, and I'm going to calculate. So if I were to write the equation, I could say y equals 79.583x plus 1256.1 repeating. Okay. Based on the line, approximately how many thousands of barrels of oil will the United States import in 2015? So that's when x is 15. So I can go to my table and I can see when x is 15. It's going to be a lot of scrolling. Or I can do second calc value, choice 1, and type in 15. The problem is, on this particular problem, that's going to give me an error. Let me show you and then I'll tell you why. The reason is my window only goes up to x equals 10. And if you can't find the value on your window, it can't calculate it for you. So I'm going to go up to 18. And now I'm going to do second calculate. Second calculate value 15. Approximately 2,449.86 barrels of oil. That's how you would do that question. Alright, that's the whole thing. Study hard.